Here we are, part 2, different shirt, all good. What happens if I give you a point? Can you find trig values? So with a point, we have a different way to do it, right? We're not talking about SOHCAHTOA. TOA. Now we're talking about x and y over x. So secant, the definition is the reciprocal of the x coordinate. So secant goes with cosine. Cosine is the x coordinate, and it's the reciprocal. So when I have a point, then, oh, that's on a unit circle too. So really, let's be honest here, it's the radius over the x. So I already know x is -7. The radius is the square root of -7 squared plus -√15 squared. So if I add that up, that's 49 and 15. That's going to be the square root of 64. That's 8, I'm pretty sure. So when I get my answer then, I do the x coordinate over the radius, or sorry, the radius over the x coordinate. So the answer is -7 over 8. So we need to know our definitions. Cosecant's the radius over the y coordinate. So again, to find the radius is the square root of -17 squared plus 7 squared. That's above my pay grade. Let me see. All right. Well, try the other one. It's not a rational number, so it's irrational. So let me try it with my other calculator. Sorry about that. We got this. So it's the square root of, again, 17 squared plus 7 squared. So it's 13 root 2. And then the answer would be 13 root 2 over the y coordinate, which is 7. Cotangent is x over y. So I have everything I need. The x coordinate over the y coordinate, and you can simplify it down if you want. So I'll divide by 5, or you don't have to do that. So cotangent and tangent is one where I don't need to find the radius. The point gives me everything I need. Sine, I need to find the radius. That's 6 squared plus -4 squared. So that's 36 and 16, which is the square root of 52. 4 goes in it evenly 13 times, right? 2 root 13. So the definition of sine is the y coordinate over the radius. And if you want to, 2 goes into 4 2 times, and then you'd multiply by root 13 top and bottom, and you can get the answer. How about graphing? So if I want to know the amplitude, that answer is 4. There is no period change, so it's just 2 pi. Cosine starts at the top of the graph, and at 2 pi would be the end of one pattern. In the middle, at pi, would go down to -4, and then the middle of those points will be those, right? That's the pattern we're looking for, and then just follow that pattern, right? And then make your curve, and it's done. Doesn't have to be complicated. Here, our amplitude is 3. Our period has changed. So I'm going to go 2 pi divided by 4, so it's pi over 2. So when I start, sine starts in the middle. At pi over 2 ends one cycle. So at pi over 4 is also in the middle. And then I go up to 3, and I go down to -3. So I'm going to complete all these points. And honestly, I'm going to go up and down. I'm going to go up and down, up to 3, down to -3. Up to 3. Down to -3. And it's done. Here, the amplitude is 2, and the period again is 2 pi because it hasn't changed. Starts in the middle at 2 pi, and then again in the middle, and then it goes up to 2, and it goes down to -2. And then I can follow that pattern to the end of the graph. Perfect. Here, the amplitude is 2. You know you should have to do this first on your own. And then instead of dividing by 2, we'll multiply. So now the period is 4 pi. So sine starts here in the middle. At 4 pi ends one pattern. That's one period. In the middle will also be the middle. And then between the first two middle points, we go up to 2. And then the next two middle points, we go down to -2. And then we follow that pattern across. All right, turn the page. Secant. Secant doesn't have an amplitude, but it does have a period, which is 2 pi. Secant starts with like a vertex, and that's at 1/2. And then at 2 pi, it's the same vertex at 1/2. Exactly in the middle is the lower vertex, which would be at -1/2. And then we have asymptotes. Oh, I got color. So in between the vertices are asymptotes. So exactly in the middle of the vertices, that's the pattern we're going to follow as we go across. And the vertices alternate up, down, at 1/2 and -1/2. And then it kind of curves up like a parabola. It's a little flatter than a parabola, but it's okay, like a parabola. And there's your graph. All right, cosecant. The 3 tells me the vertices. And then the period is going to be 2 pi times 2. So you do the inverse of what you see. So that's 4 pi. So we're going to start with an asymptote, because cosecant starts with an asymptote. And then at 4 pi, we're going to also have an asymptote. So that's the beginning and the end of the pattern. Exactly in the middle is also an asymptote. It's kind of like sine, what goes middle, middle, middle. And then in between the first two, we go to 3, and then curve. And we go to -3, and we curve, and just follow that pattern across. Here's an asymptote here too. There you go. See the grumpy old man, just like me, looking at you. Can you do trigonometry? Look at that grumpy old guy. All right, number 43. So the period would be 2 pi, and then instead of dividing by 3, we multiply, so that gives me 6 pi. Tangent starts with a point right here in the middle. And then at 6 pi, oh, I don't even have, oops, I'm sorry. For tangent, it's not 2 pi, but it's pi. And when you multiply, that means the end would be at 3 pi. So right here at 3 pi. Exactly in the middle is going to be an asymptote. And that's the pattern. Point, asymptote, point, asymptote. Now, in the middle there, tangent goes up. So this 4, find the middle. So it's 1, 2, 3, right here. So find that middle, and it goes up to the right. And then here, find it down to -4. And it goes down to the left. And up to the right. So there it is right there. It goes like this and like that. Perfect. Cotangent, again, the period is 2 pi divided by 2 pi. It's pi divided by 2. Tangent and cotangent start with pi. They're the only ones that do that. Pi over 2. Cotangent starts with an asymptote. And so at pi over 2 is an asymptote, and then every other is 1. So there's the pattern. And in between, we're at zeros. And then the 2 means we go up to 2 on the left and then down to 2 on the right. And there it is. For 45, the period again, this is 2 pi divided by 2. That's pi. So the number you don't see in front is a 1. So the vertices at 1 and -1. So here at 1 and then go to pi, and it's also at 1. And then in the middle here, it goes down to -1. In between those vertices are asymptotes. And that's the pattern. So you just follow that pattern all the way across. And then in between, put your vertices. That's enough. And the upper vertices go up, and the lower vertices go down. So make sure they don't cross over. Again, you see my grumpy old man there. Maybe it's a cute doggy. 46. Tangent, don't make the mistake. It's pi divided by 2. Starts in the middle. We go to pi over 2. In the middle there, we have an asymptote. And there's our pattern. So once I know my pattern, I just go across with my pattern. Make my life easy. And then zeros in the middle. The last thing I need to worry about is that 2. So in the middle there, it goes to 2 and folds up, goes to -2, goes to +2, goes to -2, goes to +2, goes to -2, +2. I can do this one, and so on. And there's your graph. Turn the page. More graphing. Cotangent. The period is pi, and we multiply times 3, so it's 3 pi. So it starts with an asymptote. We go to 3 pi, also an asymptote. And in the middle is an point, a 0, right in the middle, just like that. There's a 1 in front you don't see. So in the middle here, so I go 1, 2, 3, 1.5 here. We go to 1, and it goes this way. And I go in the middle, I go to -1, and it goes this way. And that's the pattern. Number 48, cosecant. The period, 2 pi times 3. That's 6 pi. So cosecant, like cotangent, start with an asymptote and find where 6 pi is. Exactly in the middle is going to be another asymptote. In the middle, in between them is the vertices. So we're going to start at 3, and it folds up. And then we go to -3, and it folds down. Oh, some fun. Here we go. So for these, we need to do a few different things here. So it's still good to find the period, which is 2 pi divided by 4. But we have other things to find. Like this one has an amplitude, that's 2. This one has a phase shift, which is -pi/2 divided by 4, which is pi/8. So it's -pi/8. This tells me where the graph starts. What's that? Vertical shift, which is the midline, is at -2. So a few things I'm going to do. First, I'm going to draw the midline at -2. This is now the middle of my wave, so I have some direction to go from that -2. Then I'm going to go to -pi/8, which is right here on the left between 0 and -pi/4. And then cosine starts at the top. So the amplitude is 2. So from the pencil line, I'm going to count up 2 right here. So from the pencil line, I count up 2, and that's the max of my wave. Then I'm going to go to the period, which is at pi/2. Now on my graph, pi/2 is 2 to the right. So I'm going to count 2 to the right and put down a point. And then in between those will be the lower part of the graph. So from the pencil line, I go down 2. And then I'm going to follow that pattern. I'm not going to worry even about the middle part as much because it's so squished together. So I'm just going to focus on those points, the high points and the low points. So as I go along, that's what I'm going to be focused on. And there's your graph. Okay, amplitude is 4. If you want to, that -2 can go here so you don't get confused. So you can put the subtract 2 at the end of it. The amplitude is 4. The period is 2 pi/2, which is pi. The phase shift, where we start, is going to be +pi/2 divided by 2, which is pi/4. And then the midline or vertical shift is at -2. So we're going to start at -2 again. And I'm going to draw a line there that shows the graph is going to be around that line, -2. Then I'm going to go to the phase shift, which is at pi/4. And sine starts in the middle. So on that pencil line right here at pi/4, that's exactly where it starts. And then the period, which is pi. So pi is 1, 2, 3, 4 to the right. So I start here and go 1, 2, 3, 4 to the right. And then I put another one in the middle. And then it's going to go, the amplitude is 4. So from the pencil line, I go 1, 2, 3, 4 up. From the pencil line, 1, 2, 3, 4 down. And now you've drawn it and know your pattern. And then once you have it, you can draw it. And there it is. All right, The amplitude is 3. The period is positive pi over 2 divided by 2, which is pi over 4. The phase shift is positive pi over 2 divided by 2, which is pi over 4. And then the vertical shift, the midline, again, is at negative 2, whatever that number is at the end. So again, at negative 2, I'm going to draw a pencil line across there. I'm going to go to the phase shift, which is at pi over 4. Oh, this period is wrong. The period should be 2 pi divided by 2. So the period is actually pi. So we start with 2 pi divided by 2. The 2's cross out. It's just pi. But we are starting at pi over 4. So at pi over 4, sine starts right on the midline, the pencil line. And then pi. So if I count 1, 2, 3, 4. So from here, I count over 4 to the right. And then put your middle point down. In between the first two from the pencil line, I count up 3. 1, 2, 3. From the pencil line, we count down 3. 1, 2, 3. And then we just follow that pattern all the way across. And that's fine. And you did it. All right, 52. Uh-oh, last one. The amplitude here is 4. Let's see if we do this right. Period is 2 pi divided by 2, which is pi. The phase shift is negative pi over 2 divided by 2, which is negative pi over 4. And then the vertical shift or midline is at positive 1. So now we're going to find positive 1, and we're going to draw a pencil line across here. And that line is going to direct the wave around that pencil line. The phase shift's at negative pi over 4. So start at negative pi over 4, and sine will start right there on the pencil mark, or midline. Then our period is pi, which is a 1, 2, 3, 4 to the right. 1, 2, 3, 4 to the right. Exactly in the middle is another mid one. In between here, from the pencil mark, we count up 4. And then from the pencil mark, we count down 4. And that's the pattern that we're going to follow all the way across. And that's enough. And then we draw our wave. Perfect. All right, enough of graphing. Last page. All right, can you draw an angle? Yep. First step, it's more than one rotation. So I'm first going to subtract 360. Then when I draw this angle, I'm going to start here with an arrow pointing to the right. I'm going to draw my quadrants, approximate where 140 is. So that's in quadrant number 2. So I'm going to approximate where that is. Not quite 180, right? So let's say that's 140. And then when I draw it, it has to go counterclockwise, and you have to show a rotation. So it rotates and then ends right there at 140. 13 pi over 3, you might want to convert it first. That's 180 over pi. So that's 60. I think it's this. Maybe not. Let's see. So it's 60, 600, and 180. That's 780. I think that's right. 600. No, pi's crossed out. 16, 600. I think so. What am I doing? Now I'm like doubting myself. 780. No doubts anymore. Hey, that's 2 rotations. So if I subtract 720, which is 2 rotations, I'm left with 60. So I'm going to first draw the angle as coterminal 60. So there's like 60 degrees. Go counterclockwise, but you got to go twice and then end it. So it has to show 2 rotations, and then you end there, and that's the angle 13 pi over 3. What are coterminal angles? The angles that share a terminal side. Find a coterminal angle to 200. Well, just add 360 and you got 1. So it's 560 is coterminal. You could add or subtract 360. All right, do you know your unit circle? So inverse cosine of 1/2. What angle is that? So we're talking the x coordinates 1/2, so that's pi over 3. Here, root 2 over 2 is my 45 degree, right? So when it's positive, it's just in quadrant 1. Tangent y over x. So which angle, when you go y divided by x, the angle's pi over 4. This one's a little trickier. 1, 0, that's at 0. Here, this is 0, 1, so that's the top of the unit circle, so that's pi over 2. Now, when you have a negative angle for cosine, we're going to go in quadrant number 2. So for negative a half, that's now 2 pi over 3. For sine, we're going to write it as negative of whatever that angle is. So this one goes to quadrant number 2. This one is in quadrant 4, but has a negative angle. Same thing here, negative 1, so that it's negative pi over 4. Here, inverse cosine, this one is in quadrant number 2. So think of your unit circle, quadrant, which reference angle is the x-coordinate that's 30 degrees, it's over 6. So it's 5 pi over 6. Here again, it's just a point on the axes. So negative 1 means 0, negative 1, which is at the bottom. So it's the negative angle that gets to the bottom, that's negative pi over 2. Cosine is the second quadrant, but tangent and inverse sine, you have to write as a negative angle. Here, the value of cosine at pi over 2 is the x-coordinate there, which is 0. And then at what angle is the value 0? And the answer is 0. Unit circle question, the value of sine at pi over 3. What's the y-coordinate there? 60-degree reference angle. It's root 3 over 2. Then, what angle is the x-coordinate, root 3 over 2? That's a 30 degree. So this is pi over 6. Here, we're going to have to draw a triangle. And when we draw that triangle, it's adjacent over hypotenuse, or x over r. This is Pythagorean theorem. 3 squared subtract 1 squared. This is the square root of 8. And so tangent using this triangle is opposite over adjacent, or just root 8, which is 2 root 2. Oh, let's get this right. They cross out, and the answer is 2/3. This is a triangle question again. So sine is opposite over hypotenuse. That's 24. 25, take away 4. So this is square root of 21. Or 5 squared, take away 2 squared. And then cosine is adjacent over hypotenuse. So it's done. Again, this is a triangle question. So it's opposite over adjacent. 3 squared plus 1 squared is the square root of 10. And sine then would be 3 over root 10, or right, multiplied by root 10, it's 3 root 10 over 10. All right, last questions. Can you solve an equation? So get sine theta by itself. So we're going to subtract 1. And then where on the unit circle, these are all going to be positive angles from 0 to 2 pi, is the y-coordinate 1. So there's only one place for that angle. That's at the top of the circle. So the answer is pi over 2. Often for this, I just draw it like that and go, okay, it's up there. That's the only place where sine is 1. One answer. Here, add 1 and divide by 2. So we're thinking the x-coordinate. Now, who's its partner? Well, it's root 3 over 2. So it's either positive or negative. There are 2 spots here. So I recognize it's a 60, which means it's over 3. And then what quadrant are we in if x is positive? Well, positive, positive is quadrant number 1. Positive, negative, it's in quadrant number 4. So make sure that we have quadrant 1 and quadrant 4 in our 2 answers. Here, at what angle are x, this is the y-coordinate, and the x, at what one are they equal to each other, but one's positive and one's negative? So at 3 pi over 4 and at 7 pi over 4, at those angles, the x and the y-coordinate are the same number, but one's positive and one's negative. Last one, get tangent theta by itself. So we're going to add 3 and divide by 3. So where is tangent equal to 1? Well, that's y divided by x is equal to 1. So which point when you go y divided by x equals 1? So that's clearly a 45-degree reference angle, and it's positive. So where is tangent positive? So if all students take calculus, it's positive in quadrant 1 and quadrant 3. So my 2 answers for the angle then would be pi over 4, and the second one would be 5 pi over 4, which is in quadrant number 3. I know I went really quick, but you should press pause and try it first, or go back and listen to it again. Anyways, there's your trig review. Mr. G Math, over and out. Till next time, I believe in you. Great job finishing the study guide.